Good afternoon, good morning, or whatever you are. Welcome to this webinar. It is the first time we run this webinar. It's about intrinsic safety versus EXD or explosion-proof or flame-proof technology. Not versus, what the comparison between the two in the plant. It's a new webinar. Our host is Bob Johnson. Most of you might know him. He's a super expert in the subject. He's been I used to say 30 years, but some years have gone by. Maybe now it's 35 year plus experience.
Yeah, I know it's creeping up. It's well, 38 now. So
wow, so soon would be over close to 40 years.
Almost 40 years, yeah.
As an EX in this world, and is a CompEX instructor, also an instructor for the ICEX CompEC scheme, member of the US ULSTP committee. So, he knows quite well the subject. Before we began, let me give you, only 5 minutes introduction of GMI, who we are, what we do, and why we do it. Since we are sponsoring the webinar, I have to do it, GMI is a safety company. We basically design and manufacture intrinsically safe and seal certified interfaces, devices for automation packages, which are used in most industry where seal or EX is required, such as oil and gas, petrochemical, food and bev, and so on. We have over 40 years of experience. We're very proud to have all our manufacturing done here in Italy, in our headquarters. On the other hand, we are global players. We're present in all the continents through direct subsidiaries. Next, here we go. Well, now 9 became 8. But yeah, guys, what happened between Ukraine and Russia, and totally one of those had to go. But we have many distributors, and we're about 200 people, super dedicated, and we've done many projects. One big project we did last year that I'm quite proud of, it was Pemex Dos Bocas, the new huge refinery built in Gulf of Mexico. And we also have a division that runs courses, webinar, training, for which we are here today. We try, because our products are safety products, so we try to make them as safe as possible. So we have state-of-the-art technologies, 100% traceability, 100% testing. We use a highly automated manufacturing facility, which is state-of-the-art. We offer 5 years warranty with a 10 years availability. And of course, we do this because we believe in a safer world. Next, Bob. These are the product. No, these are the certification that stands behind my words. So we have, certification all around the globe for our product. We also have a functional safety management certification up to SIL 3, ISO 9001, ISO 14000. Now we have ISO 18000, process rich compliant, and so on and so forth. And the product we manufacture are, next, here we go, IS barrier, up to SIL 3 certification, safety relays, also SIL 3 certified, with and without line monitoring. We have a line of isolators, non-IS, but they are also SIL 2 and SIL 3 certified. Power supplies, again, with EX and SIL certification. Multiplexer, temperature multiplexer, digital multiplexer, HART multiplexers, SPD or surge protectors, some loop indicators, and again, services. I'm not sure what's next. Well, of course, the list of our customers. Basically, we serve mostly all the Macs, from Schneider, ABB, Yokogawa, and so on. Many EPC we work with. We have a lot of OEMs where we supply our product on, and then they go into the field. For example, I was trying to remember the name of that one near you. Used to be called Carrick, but today Neighbor Drilling. Yeah. And on all the drilling rig, there are 200-300 of our barriers on there, and then they go out in the field, and they're very reliable. Yesterday we were given a presentation of our PPM, our return rate is 150 ppm, part per million.
Wow.
And we are talking about 20, 30 unit return every year over a couple of 100,000. So,
wow. You'll have to add PMEX to this list too.
yeah. Okay, so, safe product, reliable product, and great guys to talk to you about safety. Yes, Bob, it's all your Bob. One last thing, if there is a way for you to get in touch with us is to ask questions through the question and answer box. You can see there somewhere. We also have collected the question you posed through the registration. We will answer those at the end. Okay, Bob, it's all yours.
All right, thank you, Paulo, and thank you everybody for participating. I know looking at the list, we have people from North America, we have people from Europe, we have people from Southeast Asia, so we're kind of all over the world with this one. So hopefully this will be relevant. Yeah, as Paulo mentioned, this is a new topic that we hadn't done before. And actually, it was kind of presented by Paulo suggesting doing this one. And of course, GMI is a manufacturer of intrinsic safety. I don't work directly for GMI, so you might think that this is all biased towards intrinsic safety. And but I've tried to do this and put this together to really give you the information to make a good informed decision as to, of the two major protection concepts that are out there, what's the advantages and disadvantages of both, and then try to look at it from a cost of ownership, also as well as maintenance. It's one thing to buy something and then do it, but then you've got to live with it, right? So there are definitely some distinct differences between the use of Flameproof versus intrinsic safety. In some of our previous webinars, we've talked about other protection concepts, so we won't get into that today, but certainly I would encourage you to go to the GMI YouTube channel and you can find out more about, we've had topics on markings of EX equipment, all the various protection concepts and various other topics that hopefully will be of interest to you. So this one today, a couple little generalities, and I think most of you probably understand a lot of this. So maybe some of this might be a little bit of review, but basically Flameproof is known as EXD. The legacy concept, if you will, was called EXD. Anything new that's being produced by manufacturers of Flameproof will actually now be known as EXDB, because we've now incorporated what are called EPLs into our protection concepts. So where, again, an EXD product that we used to always know and love is now being known as EXDB. And the B is basically telling us that we can use this particular product in a zone 1 or zone 2 area. And there are some other EXD protection levels, if you will. There's actually now an EXDA, which we did have a question on a little bit later, and we'll cover this a little bit later on. And then there's also what is called DC, which is actually one of the end concepts that has now been renamed and thrown into the 60079-1. So Flameproof, it is limited basically to zone 1 and 2 locations only. The concept of Flameproof, it works on the principle of containing an explosion and not allowing the hot flaming gases and particulates to ignite the surrounding atmosphere. So it is more of a mechanical means of providing EX protection than an electrical means, right? We're talking about the mechanical strength of the enclosure. We're talking about things like flame paths. We're talking about how can we release that hot flaming gas without igniting the surrounding atmosphere. And we assume, by the way, that these boxes, these enclosures will actually breathe. So we assume that for the most part with EX equipment, with the exception of pressurized enclosures, that any flammable gases that are surrounding a piece of electrical equipment will actually work its way to the inside of that electrical equipment. And that's where we really have to be concerned with. So again, we use flame paths to cool the gases. There's tight machine tolerances and high strength walls to contain the explosion. The big advantage of EXD, this allows general purpose components like contactors, relays, to be used safely in a hazardous area. Very, very common technique used worldwide. It's a fairly simple concept to understand. There are certainly pros and cons to it, but it is very, very widely used and it's used very safely. It is not limited on energy. High-powered equipment can be used safely with any EXD equipment. There's actually products on the marketplace that there's actually medium voltage switchgear that you can, some manufacturers actually build out of flame-proof enclosures. These can get obviously extremely large, extremely heavy, but certainly in many cases, that might be the only way that you can address putting some of that equipment into hazardous areas. So that's a little bit about flame-proof. So some of the advantages, again, it's easy to apply. We can make almost any electrical component suitable for hazardous locations. It's very robust construction. That's a nice way of saying it's heavy. So it is very robust, and it can be very cost effective depending on the products involved. And then we can also combine with other techniques. So for example, the enclosure that you see over on the right-hand side, that's a combination of a flame-proof box on the top where we might have arcing and sparking components. And then nippled to it is what is called an increased safety enclosure, where we have non-arcing components. So we can actually combine flame-proof with other techniques, and it is commonly used. Things like a control station that might be out of plastic, you will find the switches in many cases will actually be EXD rated. And certainly for motors and other products like that, it's a very common protection concept. So there are some things, however, that are downsides of the use of flame-proof. One of the things that we see a lot is not tightening of the bolts correct, right? Painting of the flame-proof joints, that's a no-no. Wrong corrosion protection, right? Usually these cast enclosures are made out of a cast aluminum or aluminum. You do find some cast enclosures made out of stainless steel for extremely corrosive environments, but they get to be extremely expensive. One of the issues is scratches in our EXD flame-proof joint. This is something that, we have to be very, very careful with our flame-proof joints. One thing that people don't remember a lot is obstacles of having a flame-proof enclosure, a flat joint flame-proof enclosure. There's a minimum distance that we need to require or minimize or maintain, if you will, away from that flange. Certainly using the wrong cable glands and blind plugs, improperly installed cable glands. Again, they are heavy. And when I say they're difficult to service, typically that means we have to remove all these bolts, which takes time, energy, and certainly we have to do lockout, tagout when it comes to that type of application, or at least get a hot work permit and gas-free certificate. Whenever we make changes to the contents of an EXD box, that potentially could affect its certification. We have to be very careful about that. And then finally, a lot of these enclosures will come from the factory with a U component certificate. This is one of the things I do inspections a lot, and I'll see flame-proof boxes that will be out there with a U component. And that means that basically it was brought into service as an empty enclosure, and then somebody after the fact installed some equipment inside it, and yet the certificate and the label only shows that it's a U component certificate. And basically the standard says is that we cannot use U component certified products without further assessment, meaning that in effect, depending on the certification, we might have to resubmit this entire assembly to a certification body to get an updated certificate, which can obviously increase the cost associated with it and time. So again, some of the drawbacks, they can be very large and heavy. The materials used, as I mentioned, they're not necessarily best from a corrosion resistance standpoint. We may require the need for sealing or barrier glands, depending on where you are in the world, depending on the requirements for sealing of flame-proof boxes. In some cases, we follow the IEC standards. In some cases, we might follow variations of those standards. So certainly we have to understand where and where not we have to use a barrier gland. And typically barrier glands take a little bit more time, and there's more potential areas in which you could have failure from the installation, but we need to keep that in mind to maintain the effectiveness of the concept. And again, this also requires an understanding by the maintenance team to replace or tighten bolts, re-lubricate threaded or flanged surfaces. And one of the things, it is limited generally to the gas group. Most of your flame-proof products will be rated for gas group 2B and 2A. They're somewhat limited for 2C applications, which includes acetylene and hydrogen. So we'll talk a little bit more about that later on as well. So what you see over on the right-hand side, you see obviously a flame-proof box on the bottom there with some bolts missing. What you're seeing at the top is actually an aluminum enclosure with a brass cable gland. And what's happened there is that you've thrown that enclosure into a salt-laden environment, and brass and aluminum will react violently when we add sodium chloride to it, and it'll start to actually eat away at the aluminum. So an enclosure, we have to be very careful when we're selecting cable glands to go into an aluminum enclosure in a marine environment, for example, because we want to minimize that type of situation, because if that's left unchecked, basically at some point in time in the very near future, that enclosure will basically be not suitable for a hazardous area any longer. And these are just some of the examples of what you would see on flame-proof boxes, right? So up at the top, you see that in this case, it's not necessarily something indicative of flame-proof boxes in general, but obviously the use of cable glands. In this case, they're putting tape to oversize the cable diameter to make sure it fits the cable gland. Well, we can't do that. What you see over on the right-hand side, you see a light fitting that's flame-proof, and it's got obviously some water ingress inside that light fitting. So that's, again, an issue that we don't want to see. What you see down on the bottom left is a flame-proof enclosure, again, filled up with water. So some of these enclosures can certainly allow moisture to get in. We have to be very cognizant of that fact. And what you see on the bottom right-hand side is a couple issues. Obviously, bolts are missing. I mentioned to you about things like obstructions within 10 to 40 millimeters of the flange. Well, they've defeated that by basically putting a solar sunshade, and certainly the labeling is an issue as well. So these are real world examples of what you find with flame-proof boxes out in the field. When we don't necessarily, it could have been perfectly fine when it came out of the factory, but some of this stuff might be the environment, or it could be maintenance, or it could be the people that did the installation. They just didn't realize some of the things that you have to be very, very concerned and wary about. So again, just some other examples. You see down in the top left-hand side, damage to the flame paths, and that's also in that middle picture. We want those machine surfaces to be nice and flat and very clean. We don't want to see gouges or any scratches onto that surface. And certainly when we start installing things like barrier glands, we have to make sure that those barrier glands on the top right are installed properly, as well as what you see on the bottom right. And then one of the last things that we're very concerned about is, excuse me, the use of Teflon tape. This gland is going into a flame-proof box, and the technician installed Teflon tape, and that is a big no-no. We actually have to have a nice metal-to-metal surface, because the gland threads going into the enclosure threads, that's actually a flame path as well. So these are some of the things that you will find with EXD that are issues. So some generalities on intrinsic safety. Generally, these products can be used in all zones, right? So we have products IA, IB, and IC. If we have an IA barrier, we can use it in all three zones. If it's IB, it's only good for zone 1 and 2. And then if it's an IC design, it's only good for zone 2 only. The concept here is that we limit the amount of energy into the hazardous area. It is a system concept. This is one thing that people sometimes forget about intrinsic safety. It involves the use of an intrinsically safe barrier in conjunction with the end device, our field device. And we also have to take into account the interconnecting cables and any enclosures that might be located between the associated apparatus or the barrier and that field device. It is limited in energy, so it's generally about 1 watt or less. So it's suitable really only for low power applications. Every now and then I'll get a call from somebody asking, I want to make a motor intrinsically safe, or I want to make a light fitting intrinsically safe. We just can't do that. There's too much power applied to it that we need. So therefore, we're limited basically to control systems, right? Here's one thing. It is the safest EX protection concept when it is applied correctly. And that's the key thing. We have to apply intrinsically safe correctly. And we'll talk about that here in a little bit. And again, it is used for control monitoring circuits, and it's used widely for things like transmitters, sensors, anything 4 to 20 milliamp type signals. Intrinsic safety is a very, very common protection concept. So some of the advantages, when selected properly, it is the safest EX protection concept. One of the big advantages, it does allow the use of non-EX certified equipment within the most onerous zone of use. So for example, if we have a simple device, a non-energy storing device, we can use an associated apparatus with, say, for example, a proximity switch that doesn't store any energy. And that proximity switch does not require it to be EX certified. We can take a standard off-the-shelf type product and use it in the most onerous zones. So based upon that, it can be extremely cost effective. Not always, but it very well can be. And again, it is generally the best solution for low voltage low voltage instrumentation circuits, and there is little maintenance involved. Doesn't say that there's no maintenance, but there is very little maintenance involved with regards to intrinsic safety. So what are some of the things that affects intrinsically safe types of protection? Because there are some downsides. Again, it does involve the engineering to match the associated apparatus to the device. Unlike Flameproof, again, we have to take into account the associated apparatus and the end device and the cable, and we have to do some engineering. We have to do some math. Flameproof is more or less, we take a device and it's got some arcing devices, we put it in a mechanical enclosure, and we're done, right? So there's a little more engineering that has to be done with regards to selection of intrinsic safety. It is limited to the energy, to the minimum ignition energy of the gas group. It can be defeated bypassed. Now, this is true for basically any EX protection concept, but intrinsic safety is one of those concepts where, again, if we're now bypassing it, we've now got no protection, and I'll show you a picture of what that actually looks like. Also, if we are actually using Zener barriers, and there are two different kinds, there's galvanic and Zener. If we go with Zener barriers, it does require a clean earth that's separate from our normal plant earth. And in many cases, this is not practical. When we get into the offshore markets, trying to find clean earth is pretty much non-existent, right? So you don't find a lot of Zener barriers being used in marine type environments. And then finally, there's strict wiring requirements for segregation between IS and non-IS circuits. So what you see in that panel over on the right-hand side, we have our intrinsically safe barriers, and we have to maintain a 50 mil separation between IS and non-IS. And that's fine until we start doing all these loops and service loops on the inside of an enclosure. So at this point, we've now pretty much defeated or violated, if you will, the installation requirements for intrinsic safety. And again, some of the other drawbacks, again, it requires some engineering. We do need to take into account the capacitance and inductance, including the cable. And again, we do need to make sure that our barriers have a separation between IS and non-IS. So you see a picture there on the right-hand side, you see some intrinsically safe barriers, and you see a partition in between what looks like a contactor. That's fine and dandy, and that's great. We want to see that partition. But the problem is that whoever did the installation of this did not take into account all the cabling from the installation and basically violated the requirements of that separation requirement between IS and non-IS. So we need to be very cognizant of that fact when we're using intrinsically safe. The other thing is when intrinsically safe barriers fail, they fail safe, but at that point you have no basically energy going into the hazardous location. So if I'm in an area that, say, I've got a failure of an intrinsically safe barrier, maybe I'm offshore. Maybe I don't have an extra IS barrier of that type readily available, but yet I need this sensor. Maybe this is a fire and gas sensor. So I'll go and just grab any intrinsically safe barrier that I can find and I'll put it on there. Well, if it hasn't been matched to the end device, at that point, we may have a problem. We don't want to be just doing that. More likely what will happen is a technician, if they don't understand, because if we've blown the fuse, they'll end up just bypassing the barrier itself. So on your left-hand side, what you see right there is that exact situation. This was a bank of barriers that were installed, and unfortunately, the fuses blew on some of those barriers. And so the technician came in after the fact and said, hey, I need to make sure that this is still operational. So they've just bypassed the barriers. And again, in that particular situation on those circuits, we now have absolutely no protection whatsoever. And those sensors could be located in a zone 0 area. So we have now created, in effect, a very dangerous situation that we don't want to be doing. And then again, over on the right-hand side, this mixing and matching of non-IS and IS circuits in duct. Again, that's a situation that we just do not want to do. Lastly, one of the big drawbacks is creating what is called a descriptive system document. Now, this is an example of a descriptive system document that we do. We put this information into it. It's a spreadsheet, and it does the calculations. And you'll see in there, it'll tell us either yes, it passes, or in many cases, sometimes it fails. But we have to do this for every intrinsically safe circuit. It'll tell us all the parameters, the entity parameters for our field device. We have to take the input or output parameters for the intrinsically safe barrier. And then we also have to take into account the information on our cable. And we have to combine all that, and hopefully everything will work fine. One of the things about IS, it is dependent upon the longer the length of cable between your intrinsically safe barrier and your field device is going to result in increased stored capacitance and inductance. So therefore, we have to be very careful to make sure that we don't exceed the maximum cable length that is actually on our descriptive system document. So that's something else to take into account when we're designing intrinsic safety. Again, it's not necessarily something that's that terribly difficult to do, but it does need to be done. The good thing is that companies like GMI, if you ask them, they'll actually create these types of documents for you. They'll actually take that information, and then they'll actually do a lot of these calculations on your behalf. And in some cases, some manufacturers of the field device will actually, within their installation drawings, they might actually show you and say, hey, we've tested this against using this particular barrier with these parameters. And if you follow that, then you're A-OK. You still might have to create this descriptive system document and double check it. But at the very least, manufacturers are assisting you in actually putting this information together. So you're not on your own.
All right,
so
guys.
First poll question, Paulo.
We have a poll question. I've started it. And, I want to have some comments. This is the first time we hear your presentation. First of all, as Bob mentioned, there's, well, first, let me tell you about the poll question so you can answer that while we talk. What zone of use can an EXIA product be installed into? Whether it's zone 1 and 2, zone 20, 21, and 22, zone 0, 1 and 2, or zone 0 only? Only one of those answers is correct. I will not tell you which, but just give a few moments. Bob, you've been very honest. Honest, meaning not biased at all toward IS, but I was a little worried. But no, by listening to you, I can see the big difference is one has a lot to do with mechanical failures, and the other are more about the design. You have to properly design and engineer. Once you design and engineer, there's very little you can do other than, as you mentioned, bypass it. But bypass is like removing a bolt on a box. That's willful. It's, I don't know you say in English, but it's bad stuff.
Right. You
do it on purpose. I mean, it's not contemplated by standard. You cannot do something like that. But on the other end, one is you have to properly engineer it, do it right, and then it should be A-OK. The other one, even if you do it properly, in time can degrade because of corrosion or other issue. That's what it came across, that's what I got. Am I right or wrong? I don't know.
No, you're absolutely correct, because like I said, intrinsic safety, I think, takes a little more time up front for the designer to spend the time to do the calculations to kind of make sure, because at the end of the day, that's really, if it's designed properly, again, intrinsic safety is one of the only protection concepts that's suitable for giving away the answer, but I think most people have answered by now.
Yeah, the answer is there. I'm sharing it.
Okay, yeah.
C was the right answer, right?
Yep, it's good
And
for
most of that, I don't know, you see the poll?
Yep. So what's the issue with 20, 21, and 22? It doesn't necessarily mean that you can't use it for those, but those are dust hazards, right?
Right.
And so that's actually kind of correct as well, because intrinsic safety, certainly IA can be used for dust hazards as well. So really B and C, but most people understand it for gas applications. And the problem with D is, and this is actually one of the questions that we use for some of the training programs that we assess people against. The problem with D, and we automatically look at it, we go EXIA. A means zone 0. Well, that's true, but it also means that you can use it in a lesser zone as well. So
in the US, it means division 1, right?
Yes, well, IA would be division 1, but if we have a product that's suitable for division 1, we can use it in a division 2 area as well.
Yeah, of course.
So it doesn't mean you can't use it in a lesser area, or if you say my product's suitable for division 1, then can I use it in division 2? Yes. Same thing holds true in the international world.
Yeah, but I meant that if you are in division 1, you require an XIA barrier.
You would require an IA barrier,
which is a lot more stringent in the US, because division 1 is concludes 0 and 1, so it's
that's right.
wider scope. Okay, we have some questions, Bob. I don't know if you want to answer those. They pertain to enclosure. We got Krishna asking if an EXI concept, junction box, needs to be certified or not. Yeah, so that's a good question, because you mentioned something about that. Yeah, it's actually quite an interesting topic, and it's a good question. So yes, to answer the question, for EXI, do we need field junction box to be certified for use in hazardous area, or can we use only IP certified boxes are okay? So what the standard actually says, if we have a single circuit, so say we have a junction box with just literally maybe a single pair coming in and a single pair going out. What the standard actually says, and this is based upon the IEC standard, don't take this everywhere, but based upon the IEC standard, yes, you can use a general purpose enclosure. However, if we have two circuits, so now we have, one circuit and then another circuit, and maybe we're breaking off going into, one field device, and then another circuit is going off to another field device. At that point, what the standard says, it shall meet the construction requirements of 60079-0 and meet all the impact resistant requirements and everything else. So what that in effect means is that I do need to have a certified box anytime that I have two or more circuits going into a junction box. But a single circuit, I can use a standard IP rated enclosure. So it really depends on how you're doing it. How about the terminals that are used within these boxes? Do they need to be certified? If it
is a two or more circuits, then we have to meet all the creepage and clearance requirements. If it is a single circuit, then we just need to meet the general purpose requirements of whatever it is in the world in which you're basing it at. So, if you want to take it to the extent, could we, for example, general purpose wiring here in the United States, we could use what are called wire nuts, right? So we could have conceivably in a division 1 area, we could have a junction box that has a single circuit. We could put that in what is considered to be maybe a NEMA 3R box, which is like a NEMA IP54 type enclosure. And we could put wire nuts in there for that single circuit, and that would be suitable. But now if we have two circuits, then we have to meet all the creepage and clearance requirements. So this would entail the use of generally certified terminal blocks.
Okay. Well, there's a question that, we talk about one thing that is very important in IS is to maintain distance between the IS wiring and the non-IS wiring. The
Yeah.
standard, I think, dictates 50 millimeters and some 500 volt of isolation, something like that. And the question is, can we put in the same box or on the same cable tray? Yes, providing you have some kind of separation, right?
Well, yeah, there's a couple things. Yes, so the question does come up a lot. Can we put IS and non-IS in the same tray? Yes, you can. Can we put it within the same enclosure? Yes, we can. The outside of the enclosure, right? If we're running, say, instrumentation cable and we're running IS, we can run them right next to each other, the two cables, as long as we have a separation. Or it does allow within the IEC standard that one or both of the cables shall be shielded or armored. So we could have a situation where maybe we have instrumentation cable that's an armored cable, and right next to it, we could have an IS cable that might have shields, and we literally put those right up next to each other. That's acceptable, okay? If neither one of those cables has a shield or armor, then at that point, we have to either separate it by 50 mils, 2 inches in the tray, or we have to have a partition that goes up 25 mil and then comes down 25 mil. So it depends on the cable that you're using, and it depends on how you're installing it. One thing you cannot do, however, and this is kind of a follow-up question to that, we cannot combine IS and non-IS within the same cable. So if I have a 12 pair cable and I've got 2 circuits that are IS and the rest of them are non-IS, I cannot run a combination of IS and non-IS within the same cable. I'd have to run 2 cables.
Bob, all this, we were talking about ICEX as a standard, 60079, 11, 14, there's 25. And the question is, do they apply in North America? Or in North America, you have your own standard.
Right.
You have the UL standards, right?
Yeah, we do. So we don't follow 6.0. So the installation standard for IS, there's 2 of them. And I think we have this later on in our presentation.
Okay, fine.
But we have in the international world 14, and then we have 25. So 14 deals with simple circuits. 25 deals with much more complex circuits. So maybe we have multiple input sources, a single barrier, or multiple barriers, or different types of applications. Within the U.S., we had an ISA recommended practice document that is used for IS, but basically that's reflected straight in what is called the National Electric Code, the NEC here in the U.S. Formally, it's called the NFPA 70, and all the information as far as installation of IS is going to be located in Article 504. And that information is where you'll find segregation, cabling, all the stuff that you have to do. If you're doing something, some of you may have heard of API recommended practices. So the American Petroleum Institute comes up for recommended practices specifically for the offshore market. So depending on where you're going in the offshore market, you might follow an API recommended practice. Well, the good thing is the API recommended practices for intrinsic safety follow, in effect, the same requirements of the NEC in Article 504. So they're one and the same.
Okay, we keep getting a lot of questions. We need to move on, but I think some you already replied. If isolated circuit in the same junction box, the box needs, so if you have more than one circuit, the box needs to be certified. That we clarify.
Yes.
And then we clarify that we cannot run the same cable in the same cable, like a multi-conductor cable, IS and non-IS, because the standard says we need to keep separation of 50 millimeters. How are you going to have 50 millimeter in the same cable?
Well, yeah, I mean, the argument could be, though, what if all my individual core cables are shielded, right? So say I have one, let's make it simple. I've got a 2 pair. I've got one pair that's IS, another pair that's not IS. Both of them are going to be shielded, right?
Okay.
Okay, we meet the shielding requirements, but now when we exit out of that enclosure and we remove the shield, as soon as we've removed that shield, we'd have to remove it and leave at least 50 millimeter or segregation in some way, shape, or form. And basically what the standard writing committees have all said, well, that's now, we're relying upon the operator technician to make that call and do all this good stuff. So the standard writing committees are basically all pretty much in agreement to say, no, we just don't want to have that potential happen. Let's keep it a little more definitive. We'll say IS in this cable, non-IS in this cable, and we'll separate it that way. So that's the reasoning behind that, why that's put in.
We will answer some more questions later on, guys. Let's move on. Otherwise, we won't reach our bottom.
We'll try to get to some of these questions as we go along.
Most of them we got to.
So there you go, right? Installation standards are located in the NFPA 70 Article 504, excuse me. In Canada, we follow the CSA C22-1 Part 1, Section 18. And again, the API recommended practices in the U.S. Code of Federal Regulations. The good thing is for intrinsic safety, it's like pretty much worldwide, almost anywhere you go in the world, these concepts like separation and 50 mils and all this and the types of cables, we're all pretty much following the same thing. We're doing the same thing. So while I don't want to tell you absolutely everything that I've told you is acceptable worldwide, right? But generally speaking, if you follow these requirements, you're going to be okay, no matter where in the world you may be doing intrinsic safety, okay? But these are the documents that you do want to make sure that you check out and double check, obviously, before you do any specific detailed design. So just a couple last slides and we'll get into the Q&A. Because everybody always asks, how much does it cost to do intrinsically safe versus flameproof and all that good stuff? And here's a real simple example, right? So here's a transmitter application. This transmitter could be EXD and it can also be EXIA. So if in this case the transmitter basically doesn't change, it could be it's able to be used either way. So if we wire this up as EXD, we might need to use a barrier gland, which is going to run you maybe $40, depending on the size, maybe less, maybe more, wherever you're located in the world. But if you use $40, and then you probably are going to use an armored and jacketed braided type cable, or maybe steel wired armor cable, and it's going to be something maybe like $6 per meter, something like that, just to kind of give you an indication. Now, if we take this and we do this under intrinsic safety, again, the sensor, the transmitter hasn't changed. It's the same unit, but now we don't have to use a barrier gland. So now we're using an EXE gland. That's just a single seal. The material cost will obviously be much less than a barrier gland. Now we're using maybe an unarmored cable. So we don't have to worry about that. It's going to be obviously a less expensive. But now we incorporate an intrinsically safe barrier. So there's some cost associated with that. So if you look at just this one simple application, obviously, if the cable run is extremely long, well, that's where you're probably going to be saving some money, right, on a single circuit. You're going to save a little money on the cable gland. Certainly from an installation standpoint, you can save a lot of time from an installation standpoint using those particular glands versus a barrier gland. But then again, you still have to run it back to a cabinet being protected by intrinsic safety. So every installation is slightly different, right? I hate telling you that, every time intrinsically safe is going to be a more cost-effective means than maybe flameproof. But, in my experience, what I have seen generally, again, if you do intrinsic safety correctly, you have to spend some more time up front. There's some engineering cost associated with that. You also have to make sure that you keep this separation where you don't have to do that with flameproof. So that may take into account, you might have to make your enclosures a little bit larger where you're combining IS and non-IS, maybe in your control panel. So there are some other costs associated that are not captured here, but just showing you just kind of a material cost. Generally, IS, the longer the length of cable, can be a lot less expensive if it's done.
Bob, if I make a quick calculation, sorry, 1 second only.
Yeah.
I didn't turn off my phone. So.
No problem.
No, basically, if I was making a quick calculation, assuming $100 per barrel, which is a lot, it's an II barrel, at 30 meters, you're already saving, you're basically 30 meters, the difference between the cables. And then if you add the $20, $30 difference in the cable gland, you're basically, 10 meters difference. So when you are more than 10 meters, you start saving money. And of course, you have to consider how much money you save on an IS barrier, an IS application versus my upfront cost, engineering cost, and so on.
Of course.
Like if you have, we do projects, we did a project, like I mentioned, with those smokers, we have maybe, I don't know, 70,000 IO. So I don't know the length of the wiring, but, assume 50 meters. It's a hell of a lot more.
Yeah.
It's a lot of money that you save.
And it can be, but here's also a caveat to that, right? Sometimes some customers say, hey, look, I need to use armored cable because I want mechanical protection just to have that mechanical protection. So you might have some customers that say, look, the cable cost for me is a non-factor because I'm going to use armored cable regardless if it's IS or non-IS. So
that's a good point you have there.
Yeah, so just be aware of that. I mean, again, we can go and say, hey, IS is always going to be less expensive. Yeah, it can be. And in some cases, it can be significant, right?
Let's say it cannot be more expensive. Then
I would say that
maybe they come out across, even if you use the same cabling, then as you say, you probably come out the same. And then it's about, what we discussed earlier. Okay, didn't work.
Yeah.
I'm trying to make my job. My boss paying my man.
I know. We want to sell barriers. I get it. So there are some costs associated with maintenance, right? So EX installation shall be inspected once every 3 years. Now, that does not necessarily mean that we have to open up every flame-proof enclosure. It doesn't mean that. It does mean that we have to do at least a visual inspection of every piece of EX equipment. The issue is on flame-proof equipment because it's subjected to a potential corrosive environment. Then all of a sudden we have to open it up. We might have to open it up. So that now involves removing bolts, de-energizing, doing all this stuff. So now we have to do a full detailed inspection. Generally, IS loops can be worked on while energized. So that's a big factor that we can do some things on an IS loop. So there are some advantages on intrinsic safety from a maintenance standpoint. But and when we do inspections of intrinsic safety, really the key thing is, and what I look for, right, for an installation that's already there, I'm going to look to see, are the barriers that are installed, are they the same barriers that were originally on my drawing? And did I put any jumpers, right? Have I bypassed the barriers? And then I'm going to do a visual inspection of the circuit. Is the cable damaged? Is the end device still in good shape? If it is, then I just don't touch it, right? I leave it alone and I say everything is good and we leave it alone for the next 3 years.
So here we have another poll. Let me launch it. It's about what protection method intrinsic safety constitute. It's either quenching or cooling of the gas vapor, removing the explosion of vapors from the relevant surfaces, limiting the amount of energy that can be released into the hazardous area, or eliminating or reducing the heat spark in the hazardous area. It's quite easy, I would think, but let's see if you guys can answer. In the meantime, I pose another question we got from our viewers. Should we seal the conduit when we put unarmored IS cable in a conduit?
So that's kind of a interesting question. So if we have unarmored cable, it depends, okay? If we don't have to use conduit, but if we have conduit, we very well may have what is considered to be open conduit, meaning that we use the conduit as mechanical protection around the cable. Say we're using a non-armored cable. So we want to protect the circuits from any mechanical damage. But open conduit is basically that. It's open at each end. You would run your cable inside the conduit, but you don't have to seal it. Where you run into issues on conduit in general, if we're having enclosed conduit, where we go from an area of greater hazard to an area of lesser hazard, we have to be concerned about boundary seals. And then we also, when we're talking about flameproof, we do have to seal off. So for example, if we had a flameproof box that is enclosed inside an associated apparatus, a barrier, well, the primary thing is that we have to actually seal that cable coming out of the flameproof barrier to maintain the flameproof rating of that enclosure. It's not so much for sealing around from an IS perspective, it's to seal the flameproof box. The same thing could hold true, well, generally speaking, if we have a flameproof transmitter that might be EXD, but we're wiring it up as EXIA, we don't have to seal it. At that point, we can use, again, an industrial cable gland or an EXE cable gland for that particular type device. And that's the only requirement.
All right, well, I will terminate the poll. It looks like every single one replied the correct answer.
Yep.
Which is limiting the amount of energy. And while we are at this, I think the fourth answer that you had there, the fourth choice, has to do with one of the questions we have here. What's the difference between non-incentive and IS? Non-incentive is the fourth answer, right?
Well, actually, non-incentive is actually it's not an IEC protection concept. Non-incentive is actually a protection concept that's recognized here in the US. And non-incentive, if you will, is very similar in concept to intrinsic safety. It's basically a US protection concept that's very similar to EXIC. It's suitable for Division II only, and you do find non-incentive devices and non-incentive circuits. In the IEC world, instead of calling it non-incentive, well, we call it intrinsically safe, or we also have things called non-arcing, which would be considered to be NA, or some of these other protection concepts. So non-incentive is actually not referenced within any of the IEC standards, but it is referenced within the NEC, as well as the CEC and the API recommend practices. And that will deal, you'll see something that will be rated non-incentive, and it'll say class suitable for class 1 division 2. And it's basically low energy circuits. It's very similar in concept to EXIA. And in many cases, you'll find—
IC, not IA.
Excuse me, IC, yes, thank you. It is very similar to IC. And in fact, what you will see, you might see, say, for example, a PLC or an HMI that will say on the label, it'll say class 1 division 2, non-incentive, and then it'll say ATEX category 3G, EX, NA, NL, so forth and so on. And that's actually
this
what
means typically that it can be installed in division 2 or zone 2.
That's correct.
It's
that's
not protecting the wiring coming from a different area, for example.
That's right.
Right.
And so this label is showing you here. We get a device from a manufacturer, and you look at it and you say, "Oh, it's intrinsically safe, it's flameproof, and it's type N." So we have actually 3 different certs, 3 different protection concepts that we can use. And this gets into the point, if I go out and inspect this and I say, okay, how are we installing this? Are we using it as an EXD product? Am I going into a zone 1? Great, then I have to look and say, are my cable glands EXD? Do I need to use a barrier gland? Am I using the right cable? On the other hand, if I look at this and I see maybe a plastic cable gland, that's general purpose or something like that, immediately I might think, ooh, that's not right. Well, but wait a minute, they installed it as EXIA, and therefore it was a single circuit, though therefore I didn't require such and so on. So you have to understand when you're doing inspections, especially with a piece of equipment like this, how are they actually doing the installation? And if you're responsible for, selecting of the product, right, you need to make sure you let your technicians understand or your customer understand that, hey, if you're going to install it in accordance with intrinsic safety, then, here's a barrier that you should use. If you're going to install it in accordance with EXD, follow the installation requirements for EXD, so forth and so on. So this can get very confusing, and you're going to see more and more of this because manufacturers are saying, look, we want to have one product that you could use and install in any way, shape, or form to make it as simple. Plus, they only have one product that they have to sell, stock, so forth and so on. So this is becoming very, very common. You see this a lot with transmitters, that they'll have multiple markings and they're telling you multiple protection concepts. Again, just some of the deciding factors. I think we've kind of already talked about that, but that picture up on the far left-hand side, there's an example of a flame-proof enclosure that also could be intrinsically safe. And we see that plastic gland and we say, oh, okay, well, if we're doing it as intrinsically safe, then that is potentially okay. But normally we would look at that and say, hey, that's not right. There's a problem here. So these are just some other pictures of just showing issues with problems. So again, each concept has advantages, disadvantages. Sometimes the advantages of one versus the other is not so clear. And it may be not necessarily, if I'm looking at it from a total installed cost, you know, I'm looking at it from one perspective, and maybe another perspective might say, hey, my cost is actually better if I go this way. So you have to look at it from different perspectives as well. And again, each installation situation is different. You know, what's my labor force, the skill of the operator technician, including the designer. It all makes sense to kind of say, hey, are the engineers that are doing this, are they capable of doing these DSDs? If they're not, maybe we just go with Flameproof, make it simple. On the other hand, maybe we have very capable individuals that can create these things, or we have good manufacturers like GMI that can help us. Therefore, hey, this makes sense. And again, the environment can be a big factor. And again, in zone 0, the only real solution is IS. And again, for power applications, IS will not work, and Flameproof or other techniques may really be your only choice.
Okay, great. Well, we have last call, and we are running kind of late, Bob, but let's see if our viewer remain with us. So what does the U at the end of an EX certificate means? Are the condition of safe use of the EX equipment? And I don't think so. That sounds, it's a hex, I believe. The equipment has a component certification only. The equipment is certified for using areas involving hydrogen. The equipment is approved for use in Europe. That's a good one.
Yeah, so it actually, and I know we're running out of time. We still had some other questions that people were asking. So
yeah, we will try to run the Q&A session that we have registered, pre-registered, which I mean pre-prepared. And if you guys stay along with us, we will do it. We have another 10 minutes, no problem. Yeah. If you want to go, we understand that you can always see the registration of this webinar, which will be shared later on. So most of you have done correct. The equipment has a component certification only, a U. Yeah. And it's quite a limit on the EXD boxes, I understand.
That's right. And not just EXD boxes, but EXE enclosures, EXP pressurized enclosures. Anytime we see a U at the end of it, it means that it is not a final certification. Yeah. So
here's our presentation on which includes your question.
Okay.
So what are the factors and criteria for selection of instrument in hazardous area? Well, that's a tough. Here's the answer you prepared, Bob. You can see it, right?
Yeah, I think
I cannot. It's in a different screen, so.
No, I can see it. I have it on a small screen, but yeah. If I'm selecting instruments, I certainly need to, what standard certification is required? Obviously, we need to know, is it ATEX? Is it IEC-EX? Is it North American? Is it Brazilian? What is it? What are the project requirements, the area classification? What zone is it going into? What gas groups? Ambient temperature, ingress protection requirements, any specific site requirements, any client-specific preferences, you know, maybe spare parts or components. Maybe a facility is already using this brand, so we should stick with that. And then again, any other factors such as ease of installation, maintenance. And then usually after we do all that good stuff, right, then we finally get down to the price and availability. But sometimes it's, you know, it's price and availability. Especially today, it's tough to get products from various manufacturers. So, you know, lead times are very, very long. So sometimes the availability is really the key.
Makes the difference.
Yeah.
What about information and 2B plus H2 gas group?
Yeah.
So hybrid protection method.
Yeah, and this is a great question too. So you will find in the IEC world, we have three different gas groups, 2A, 2B, and 2C. So, and they're represented by those common gases. But 2C is acetylene and hydrogen. Well, what you will actually find now, because hydrogen is commonly used in industry and acetylene is not so much, the IEC does allow to have markings to include 2B plus a marking of H2. So in effect,
what we lost you.
Oh, you lost me? Can you hear me?
A little bit. Now you're okay.
Okay. So 2B, so when you see something marked 2B plus H2, that's telling you that the product is basically suitable for 2B gases plus hydrogen, but not acetylene. So that's what it means. Now the hybrid protection, for example, that light fitting on the right-hand side, when I'm thinking of hybrid protection is that now we're taking different protection concepts and using them in a single product. So that light fixture, for example, incorporates encapsulation, EXMB. It includes increased safety, EXEB. It also includes flameproof because there's a flameproof switch on the inside, EXDB. And I think that's it. So you have three different protection concepts in a single product.
We have a question. It's a little bit posed in a little difficult way to understand, but I'm sure you have understood. There's been changes to 6007911 edition 7. How does that impact our consultant inspectors for the use of this standard?
Yeah. So here's the thing, right? The -11 standard just came out, and that standard is the specific standard around intrinsic safety and design of equipment built around IS. The -14 standard has been around since 2013, and it has not been updated. It will be updated next year. And I suspect that what you will see, you might see some changes in the -14 standard that will reflect some of the new requirements on IS that were now published in the -11 standard. But right now, as of today, it's the 11 standard is really more for the designer of intrinsically safe equipment. So manufacturers like GMI or Honeywell or whatever, that's the latest standard that they need to follow in order to build their equipment. For the application of IS, we're still following 14 or 25 at this point in time. And I would just say that, continue to do so until the new standard comes out next year.
Great. What kind of improvement could ATEX ICX bodies implement in the future? That's a good question. Such as the regulation standard and so on.
I will just leave it at this. I did answer it, but it's
it is.
So one of the positive things that I think is really big under the IEC-EX system is that all certificates are available online. Under ATEX, it's not a requirement to do so. So getting that relevant information from manufacturers, you have to go to their website, you have to dig up all this good stuff. Under the IEC-EX scheme, I like the fact that so much is transparent. And there's a lot of things, again, I could talk for days on this topic. And as to certifying bodies, some of them are fantastic, some of them are bad. I would just say this with regards to certifying bodies. If you have a good person, people ask me all the time, and I know a lot of certifying bodies, and I deal with them. But what I always tell people is, if you find a good certification engineer or test lab engineer, it doesn't really matter who he or she works for, stay with that person, because these certifying bodies, they have a tendency, people come and go at different places. And so if you find a person that you can work well with, regardless of who they work for, and they go to another certifying body, then hey, call them up, stay in touch, because finding a good certification engineer that knows what you need and understands your business, that's very much worth gold as far as I'm concerned.
Yeah, you're very right with that.
Yeah.
Building a relationship with the people that understand you is very important. We know that very well.
Yeah.
Because also can save money, because there's a lot of cost in certification.
Yep.
How can we use Flameproof in Zone 0? I guess not.
No, you can. Because you can. So there is actually EXDA under the -1 standard. for Flameproof. However, EXDA only applies to catalytic sensors of portable combustible gas detectors. So that's
specific application.
It's a one specific application. However, there is in the -26 standard that allows you to take two independent types of protection into one unit, where if one level of protection fails, the second level of protection continues to operate.
Okay.
So for example, I could have an inductive transmitter that's rated EXIB, and it's or being protected with intrinsic safety IB, and then I enclose that with encapsulation. So that's EXMB. So I've taken two independent protection concepts that are rated in this case, zone 1 and 2, and therefore I could use that system in a zone 0. Another example could be taking an increased safety light fitting, rated EXEB, and then I could take that entire light fitting and I could put it into a D enclosure that maybe has a sight window, and I could take that entire assembly and put that into a zone 0 as well. So what you see the marking down there for that particular application would be EXDB, which is telling us Flameproof suitable for zone 1, plus EXEB, which is increased safety suitable for zone 1, gas group TA. And at the very end, we have GA, which is telling us that this is good for a gas environment suitable for zone 0. So this is different than taking multiple protection concepts like I showed on that light fixture and combining them into one, because they all have to operate successfully as a system. This is actually taking two independent protection concepts and putting them together and making it suitable for a more onerous application.
Like redundancy.
It is. It's not common, but that is actually a way that you could use, say, a high-powered device, if you will, in a zone 0 application.
Well, I learned something today, Bob.
There you go.
Are we doing any section on products that support CIP safe? What is CIP safe?
So it's common industrial protocol, fail-safe communication on safety networks. So that's not something that I get involved in. It's
maybe
very
Tino. It's
yes. Tino with functional safety. This is definitely something because it has to deal with the software and the communications, and it's absolutely part of functional safety. So
I will talk to Tino, guys, and see if I can get him to talk, prepare a webinar on this.
Yeah.
All right. And then we have the usual question: can we do webinars or all that? You can see our live webinar schedule, or on our webpage. And all the webinars have been recorded in the YouTube channel. We will share this information to those who have registered. So you see that. And I have a last quote, but I don't know where I put it.
Don't worry. There was a question that
there is a last question here, a couple of last questions. So one is, so EXT is not for zone 0. We just discussed that.
Yeah.
So e-motor cannot be installed in zone 0.
That is true. Now, mind you, here's the important thing to remember. Where do we actually find zone 0 in our facilities? The only place that we really are going to find zone 0 is inside of a storage tank filled with a liquid gas mixture of a flammable atmosphere. That should be the only place where we see a continuous flammable hazard. So it's not an area in which we should be putting a motor, right? The types of things that we would be putting in there electrically driven would be sensors, right? Level gauges, sensors, proximity switch, which we could all make intrinsic safety. But yeah, we should never, and EXD motors have never been approved for zone 0. And in reality, if we really think about it, zone 0 is an environment in which, again, a flammable gas air present is continuous. We really would not want to put a motor in that environment regardless.
Yeah, I finally launched the poll. You just let us know how Bob did. So discard my review, and I had some problem, but I managed. So how about what else? Well, thank you. Good webinars. So Bob, thank you.
Yeah, hopefully you learned something today. I had fun putting this together, and again, everything that I tell you guys, please make sure you look at your own country's specific regulations and wiring regs. And I didn't want, I'm not here to try to push you one way or the other, honestly. But give you the things to think about when you're looking at your own projects. Should I be going this direction or this direction, or even some of the other protection concepts that we haven't talked about? I'm a big believer in looking at all the options, and the more that you can think about the options, the better off you're going to make and safer you're going to make your installation.
Yes, very much so. Great, Bob, and thank you guys. Almost 95% of the people remain to listen to this. So great, it was a great webinar. Nice, Bob. We shall repeat that one day. Thank you again. Have a good day. I'm going home.
There you go.
There we go.
Ciao, everybody.
Ciao, ciao, ciao.